So now that we know what vectors are, so now what we want to do is we want to learn how to deal with vectors, right? So scalars, which are just ordinary numbers without a direction, you know how to do things like add and subtract and divide and multiply. Now we need to do all those things with vectors. Okay, so first off, so vector addition. So how do you add two vectors together? So the easiest way to start is to think about this graphical method. So you remember where you can indicate a vector with an arrow, right? So we've got some arrow, the length of the arrow is proportional to the magnitude and it's pointing in the direction. So here we've got some vector A, which has some magnitude and is pointing in some direction. So this tip to tail method, so what we want to do is we want to write all of our vectors, so draw all of the vectors as arrows, then you put tip to tail, then the resultant, so that's what the result is, so it's the vector pointing from the very start to the very end. So I always like to think of this as a treasure map, right? So these pirate treasure maps where, you know, you walk 3 paces east and 12 paces north and 17 paces south and so on. So you're kind of following, so each of those is an individual vector. You follow them one by one, and then the total resultant, so the sum of all those vectors, is the vector pointing from the place where you started to the place where you finished. Okay, so if we want some vector A plus some vector B, we want to find the resultant, the sum, right? So here's vector A, so it's some vector with a magnitude in a direction. So, and in blue here, the second vector, so that's vector B. So vector A, so we put the tip of vector A by the tail of vector B, and then our resultant, which is shown in red here, is the vector pointing from the starting point, which is here at the beginning of vector A, to the ending point, which is the tip of vector B. Okay, so that's how we add. So what about subtraction? Well, the best way to think about vector subtraction is think of it as adding the opposite, right? Because, well, and this is true in general, not just for vectors, right? So if you have two quantities, A minus B, you can also think of that as A plus negative B, or A plus the opposite of B, right? So this works for scalars just as well. So all we have to do is we have to figure out, well, what exactly do we mean by negative vector B? So what is the negative, or what does the opposite of a vector mean? Well, when it comes to vectors, there's actually a pretty obvious meaning for opposite or negative. It just means the opposite direction. So if you have a vector that's pointing north, the opposite, or the negative of that, is going to be pointing south. Okay, so now, so we know how to do addition, we know how to do subtraction, so now scalar multiplication. So scalar multiplication means we have a vector and we're going to multiply by a scalar. So all this does, it just changes the magnitude of the vector. It doesn't affect the direction. Well, that is, unless your scalar happens to be a negative number, but we know what negative or opposite means when it comes to vectors. It just means the opposite direction. All right, so if I have some vector A that's 2.3 meters west, so then if I multiply that by 2, so 2 times vector A, well, that's actually not going to be 2.6, it's going to be 4.6 meters west. So 4.6 meters west. And similarly, so let's say vector A, so 2.3 meters west, and if I multiplied that by negative 2, well, again, it's now not 2.6, it's going to be 4.6 meters east. Right, so the 2 just multiplied, 2.3 times 2 is 4.6, so remember 4.6, and the negative sign means it flips direction, so my initial vector was west, so since I multiplied by a negative, so my resultant is going to be east.